Hello, Integrated Math 1. We're doing the second day of Module 1, Topic 2, Lesson 2. We're picking up where we left off last time. So last time we left off where you had all of those lovely little sequences and you had learned about arithmetic sequences and geometric sequences, and you'd kind of sorted out your sequence cards that we cut out last class. So the deal is, we said arithmetic guys were the ones that had a common difference, that you were adding by the same thing or subtracting by the same thing every time. That if it was being added, that meant your common difference was positive. If you were subtracting, that meant your common difference was, of course, a negative. And of course, you also learned about geometric sequences, that geometric sequences were when you multiplied or divided by the same thing every time. And referred to that number as a common ratio. If you were multiplying by 2, for example, we said your common ratio was 2, r equals 2. But if you were dividing by 2, we rewrote it as a fraction. So if you were dividing by 2, that meant your common ratio was 1 over 2, was 1/2, right? That's how this stuff works. Now, what you're going to do, so you've sorted it out. You have your pile of arithmetic sequences. You have your pile of geometric sequences. And then you have those other ones that we were like, and we'll just toss those out, that we didn't need those anymore. And you'll notice here, we're looking at the screen, that you had 5 arithmetic sequences and you had 6 geometric sequences. So if you flip over a little bit there in your textbook, in your workbook, you will find pages 117 to 127. And you'll see 5 of these that say arithmetic. I bet you know where those are going to go. And 6 of these that say geometric. And there's one extra bonus one on the end. Don't worry about the blank extra special bonus one. We'll deal with that another time. Now, we're not filling out all of these today. But here's what we are going to do. I want you to glue each arithmetic sequence gets its own page. So those little cards that you would cut out, and you wrote on them the next 3 terms, and you wrote on them the pattern, and you wrote on them D equals, your common difference. You're going to glue them onto your graphic organizers. So all of the arithmetic ones, you're going to do 1 per page. All of the geometric ones, make sure they're going in the right place, 1 per page, all right? And then what I also want you to do, so you're going to do that first, glue in your arithmetic guys, 1 per arithmetic organizer, glue in your geometric guys, 1 per geometric organizer. Don't worry about the blank one. But I have an extra special bonus that the directions in your book don't tell you to do, but I want you to do this because it's going to help you. Once you've glued it in, so here I have sequence A. Sequence A was geometric, so I glued it into the top of my geometric organizer. And notice I left some space here because here's what I'm going to do. And you may have a little more space, a little less space, depending. I'm not sure that my ratios are right on my screen. But down below, I'm going to make a table with my sequence. And I'll show you with A. Remember how you did this in the very first lesson of this unit last week? How we wrote out our sequence, we wrote out the pattern, but then we made a table of our terms. Do you remember that? So I did that. So I have my term number, term 1, term 2, term 3, term 4, term 5, term 6, term 7. And then I put my term values next to them, 45, 90, 180, 360, 720, 1,440, and 2,880. So that's what I would like you to do. For each of these, you're going to glue them in where they go. Make sure you're putting the arithmetic guys with the arithmetic graphic organizers, geometric guys with the geometric organizers. And then please make just the table of values. Just use the sequence, term number, table of values, put that term value. Go ahead and hit pause to do all of that because it's going to help you do our next step. And then hit play when you're ready to move on. All right. You've got all of your tables. You've glued everybody in. They all have tables. Here's what we're going to do next. We're about to match up graphs. So if you look on pages, so we've done our sequences. We're cool with the sequences. We've got this, and that we're using it to help us predict the next sequence. Ooh, I lost my page. That's so very sad. We're doing this to help us do the next sequence. And we're going to now match it with the graphs. So here we go. On pages 113 and 115, you're going to find a whole bunch of graphs, all right? You need to cut out all of these graphs, all right? You're going to cut out all of these graphs and you're going to match them to the appropriate sequences in our graphic organizers and then glue it into the little graph section. Now, again, just like I did with the other one, I'm going to help you with the first one here. So we have sequence A, and this is why I made this table, because this table actually gives me X and Y coordinates. When X is 1, Y is 45. When X is 2, Y is 90, and so on and so forth. I have coordinates here. So I'm going to look at all of my graphs. Let's see. I start all the way down at 45 and I work all the way up to 2,880. So I definitely am looking for a graph that's increasing, aren't I? So as I look at these graphs, I'm like, okay, well, number 1 is increasing. Definitely not 2, definitely not 3. 4 is increasing, not 5. 6 is increasing, but it's negative. So I feel like I don't want that. There were no negatives in sequence A at all. So we've narrowed it down to, well, still 1, because even graph 4 has negatives. I don't want negatives. So, okay, so no. Decreasing, that's bad. Decreasing, no. This one's increasing, but again, it has a whole bunch of negatives. I don't want, there were no negatives in sequence A. This one's going up and down and bouncing around all over the place. This one's also bouncing around all over the place. Guys, I think we've narrowed it down to sequence A needs to be with graph 1. It's increasing and there's no negatives, right? Because if we look at our sequence, it was increasing and everything was positive. It just kept going up and up. So that means that sequence A goes with graph 1. So I would like you to use those tables that you just made on all those graphic organizers to help you match up the graphs. And then you're just going to glue the graph in. You'll see on the organizer, it says graph. You're just going to glue your graph right in to that section. So go ahead, hit pause, match everybody up, glue them all in, and then hit play when you're ready to check your work. All right, hopefully you hit pause and you had a chance to match up all of your graphs with the tables and glue them all in the right place. You may have to hit pause while you check as well, because you may have to flip around pages, because I just did them in order A, B, C, D on down, but of course that's probably not the order you have them glued into your organizers, because some were arithmetic and some were geometric. So we already said sequence A went with graph 1. Turns out sequence B went with graph 4 over here. Sequence C went with graph number 2. Sequence E went with graph number 5. Sequence F went with graph number 3. Sequence H went with graph number 6. Sequence J went with graph number 9. Oh, sorry, that's not it. Number 9, it's over here, graph number 9. Sequence K went with graph number 7. Sequence M went with graph number 10. Sequence N went with graph number 8. And sequence P went with graph number 11. So hopefully you were noticing the numbers that they had labeled on the y-axis, because it changed depending on the problem, and that would have helped you match things up a little bit better. So question number 2 says, what strategies did you use to match the graphs? Go ahead and hit pause, jot down what you did to help you match the graphs, and then hit play when you're ready to continue the discussion. So I use the table for the sequences as X and Y coordinates to match them with the correct graph. That's the strategy I used, right? We're going to use what works for us. Now here's a flashback. Remember with functions, remember we had a way of telling whether or not graphs were functions? Do you remember that? how can you use those graphs to verify that all sequences are functions? And you may have to flip back to the last unit to remember what trick that was that we had that helped us determine whether or not a graph was a function. Go ahead and hit pause, find it, write it down on number 3, and then hit play when you're ready to continue the discussion. Did you find it? Do you remember? The vertical line test! All of these graphs pass the vertical line test. If you were to draw a vertical line, just a line like straight up and down, anywhere on those graphs, it would only ever touch those dots once. It would never touch, if you're doing a straight up and down vertical line, it would never touch the dots more than once, although it might miss a few spots. So now that you're feeling a little better about this, let's just practice some more with our arithmetic and geometric sequences. We really want to make sure we have that down super solid. So we're on Talk the Talk. We've moved over to the next page here. I believe that means we are on page 108. So we're on page 108, and I would like you, for each of these guys, 1 through 4, I want you to write the first 5 terms of the sequence that they describe and identify the sequence as arithmetic or geometric. Okay, so give me the first 5 terms and then identify it as arithmetic or geometric. Go ahead and hit pause, work all these out, and then hit play when you're ready to check your work. How'd you do? We're on the first one on page 108. So the first term of the sequence is 8, and the common difference is 12. Well, if the first term is 8 and the difference is 12, common difference is 12, that means I need to add 12 every time. Okay, so D equals 12, I'm adding 12 every time. So fine, 8 plus 12 is 20, plus 12 is 32, plus 12 is 44, plus 12 is 56. And since it is a common difference, since we're adding 12 every time, this sequence is arithmetic. Yes, it is. Question number 2. The first term of the sequence is -9, and the common ratio is -2. Okay, so we'll start with the -9. They said the common ratio is -2, which means I should be multiplying. So I'm going to multiply by -2 every time. So -9 times a -2 gives me a positive 18, times a -2 gives me a -36, times a -2 gives me a positive 72, times a -2 gives me a -144, and that's why I have a calculator. Oh my. And because I'm multiplying by -2 every time, this is definitely a geometric sequence. Don't know what else it would be at this point. Number 3, the first term of the sequence is 0, and the common difference is -6. Common difference, and that's a -6. Ooh, difference means it's an add or subtract guy, and if that's a -6, I am subtracting 6. So I'm going to start with 0. 0 minus 6 is -6. Sorry, there's a comma missing. -6, that's a comma missing. I'm going to put my comma in. There's a comma there. Ooh, there we go. That's good. That works. That's the job. So 0 minus 6 is -6, minus 6 is -12, minus 6 is -18, minus 6 is -24. And yeah, this is arithmetic. This is arithmetic. I'm subtracting 6 every time. It's totally arithmetic. This one made you think, right? You had to work for this one. The first term of the sequence is -3, and the common ratio is -1/4. Since I see common ratio, that says to me I should be multiplying this darn thing. So I'm going to multiply my -3 times a -1/4. And I'm going to leave my answer as a fraction because that's just going to make it so much easier. So -3 times a -1/4 gives me positive 3/4. Times a -1/4 gives me a -3/16. Times a -1/4 gives me a positive 3/64. times a negative 1/4 gives me a negative 3 over 256. So it looks like my denominator is just getting multiplied by 4. And because it's negative, I keep going negative, positive, negative, positive, negative. That's how it works. Oh, common ratio, and I was multiplying. This means my sequence is dun, 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 geometric. Yes, it is. Oh, that was our last one. Well, I guess we had to go out with a bang. As always, guys, I hope you found this helpful, and I hope you found this useful. If you got questions or concerns, email me, ask me during class, or come see me during office hours. And I'll see you soon. Bye.